Alright, today on the bench, a scope that I have been looking for a while, a 182C. So the 182 are one better on the 180. They have this bigger screen, so they make the top portion bigger and put this gorgeous big screen. Hello and welcome back. If you follow the channel, you might have spied my HP 180 oscilloscope making cameo appearances in other videos. The HP 180 was introduced in 1966, and at the time was one of the first fully transistorized scopes capable of 100 MHz direct bandwidth. A variant with trace memory was added in 1968, called the HP 181, and then in 1970, a record-breaking 250 MHz scope was introduced, the HP 183. But what we have here is the fourth member of the family, the HP 182, a large screen 100 MHz scope introduced in 1972. With its gorgeous giant screen, it is my favorite of the series. This later variant was likely developed in response to the Tech 7403, a large screen scope that had been introduced 2 years earlier by Tektronix and could work up to 65 MHz. It was part of the new and still much loved Tech 7000 series, introduced in an attempt to fend off the HP 180 dominance. The similar looks and modular construction are no accident. Don't you like the great HP Tech scope wars? This one was a save. Was going to be tossed away. And I turn it on, line doesn't go on, and it doesn't appear to be anything except, woohoo! Tube is working. There's something there. I think the tube works, but the plug-in don't work. I managed to get it to do something. There you go. Haha. See? So I think it's the right plug-in. It's the horizontal deflection, the time base. I've put a little bit of a vintage waveform in there. Oh, we do have sine wave. Okay, so most likely this is working, this is not working. The important thing is that the tube and the rest is working. As you can see, I cleaned it up and I found some part that has some broken rails inside. But altogether, I think there is some hope. Let me try another set of drawers. You get these, and they come out as a pair. So this is the set from my 180D that I know sort of partially works. Okay, so that's where it has a broken rail, so it's a little hard to put in. We'll repair that if it's worth it. Oh yeah. Winner, winner, chicken dinner. Problem with this one is, if I remember well, the triggering is not working. Okay, so we have two half-working time bases, but the frame's good. And of course, you noticed the screen is blue, so that's my first blue phosphor made for photography, I think. Actually, before I go anywhere, I think I should check the power supply, and the caps are hidden back here. Do this. Wee. Alright, there is our favorite tantalum. So I just should check if those heat up or not. Also, I have acquired most of the manuals, and this will be for my scanning pleasure. I'll post them when I have scanned them at high res. Minus 100 volts, minus 12.6 volts, plus 15, plus 100. And each of them has a test point and a little adjustment. That shouldn't be too hard. And capacitors, all nice and cool. This one, nothing. All the hot stuff are the resistors, which are supposed to be slightly hot. Yeah, these tantalums, they usually never fail in capacitance, they fail in leakage, but these seem to be good. Oh, those are quarter turn screws. Oh, I can feel the Tektronix copy here. Alright. Here's my broken rail that I need to repair. This one is complete. And here are my big spray caps. And this is where you fry your mustache, because that's the high voltage portion. Whoa, very clean. And here is the other side. There is a high voltage adjustment that we'll have to make. It says 3.15 kilovolts. For a tube that size, it must have a giant acceleration voltage, and it does. 18.5 kilovolts. So that's what large tubes will do for you. You need a super big post acceleration voltage. So here in the power supply, I'm already spotting a problem, or a potential future problem, and that's another classic. The board edge connectors, they crack. So apparently you can remove the whole power supply as a block. It's not entirely clear to me how. It's not coming out. Oh, by the way, it had heatsink damage at the bottom here. I didn't notice that. Oh, maybe the entire module is coming out. Yeah, and that's going to put some pressure on my feeble connector here. Okay. Alright, well that came out, alright. Alright, okay. Works as advertised. Almost. Oh, okay. Alright, we found all of our screws and cleaned up the power supply and checked the caps, and they are all fantastic. Let's try this one over here, for example. By the way, notice the new Kelvin probes, and that allow me to be a little bit further from my LCR tester. And it's 4.1 millifarad at 56 milliohms. This should be 3.4 millifarads. So it has conserved all of its capacitance and some more. My thinking is that this unit doesn't have that many miles on the clock. It's so clean. Usually you can tell how long they have been on by how much static dust they have accumulated, and this one is very minimal. I don't think it has been used a lot. And that connector over there, those are single pincers, so it's not too bad, too critical. I think the pincers are okay. I'll just do a dab of glue on that one, and we should be good to go. Alright, not my proudest repair, but it will do. It's a piece that flaked off, and I was able to put glue underneath and put it back on, so there's actually some mechanical strength to this thing. So I guess this came out of a shock to the unit when the back fin on the heatsink was broken. And actually, while I'm at it gluing stuff, I might as well try to repair my guide here. I think I have most of the missing pieces. This guy had a big bad traumatic shock event. So this is our version of the HP puzzle. Seems like a job for the quick version of JB Weld. Puzzle part number 1. I got that one. Okay, so hopefully done with the mechanical repairs. And in the meantime, it should have been set at the back, so I can get that one in. Oh, okay, hold on a second. This tail here has been bent. It has been a little accident, so I need to unbend this first. So it's been partially unbent. So this thing has suffered more mechanical stress than it has suffered electrical stress. is my guess. There we go. So it's slid in. You can see the mechanical damage here. I need to unbend this. Don't worry, it won't hurt. You'll be fine. Yep. Alright. Oh my, yeah, we got bent in, which cracked the fin over here. I had to do it off camera. It required some finesse with the bent part. But this is why the unit didn't come out as one. Normally the whole power supply is just those two screws and the 4 screws on the back, and the whole unit comes as one, and mine wouldn't. Now it will for next time. Okay, look at this. Slides in no problem. I think we're mostly done with the mechanical work. Let's do the electrical work. We'll do the power supply adjustment. I don't expect much problem from the power supply since the cap all checked good. I have the good plugins in there in case the bad plugins do some number on the power supplies. Minus 98 should be minus 199, much better already. Minus 100 volts. Minus 12.6. In the analog instruments, it's of course fairly important to adjust those when you do the calibration. If this is not done at the first step, everything will be off. 12.598. That should be plus 15 is 14.73. 14.99. And I wish every instrument was engineered like this, with the stuff at the back and the test point right next to the pot. And this should be 100. So I'll check for the ripple in a second on the scope. Won't show it unless I find something really wrong with it. So this 100 volts, curiously enough, it's actually used everywhere in the transistorized plugins. I didn't expect that. Right, so power supply done. There is one more adjustment. It's the high voltage. Oh, that's for the transformer. It rests on the transformer. I need to get rid of this horror. Okay, it was high time to work on this. That's a whole insulator plastic here was falling apart. So I did a contraption made out of Captain tape and some foam, and that should do the trick, and we'll be able to do the scary high voltage test. 3.150 kilovolts. Quite interesting that even the high voltage has to be adjusted so precisely. Since last time I worked on the CRT episode, when we relighted some tubes, I got myself a real probe. I had to make myself one before. Oh, this is wrong. This is 3.36. Unlike the other one, the adjustments over here, I didn't see that. Okay, well, if you don't mind, guys, I am not going to put that here. I'm going to read it to you. I am in that one. Okay, I'm not dead. Well, that was no fun. What'd I do? That shouldn't hark. What happened? Well, there sure is high voltage generated in this thing. Okay, sorry guys, since I needed my all my attention here, I turned the camera off and tried to check why it was arcing, and guess what? Now it doesn't arc anymore. It did arc for a while, then it stopped. Here, no more arcing. Unfortunately, I have no more high voltage, that's why it's not arcing, and then I can't find the beam anymore. So I have zapped something in the high voltage power supply. Yes, my favorite thing to debug, high voltage power supply. Oh no, I hate when it happens. You try your best to improve something that already almost works, and then you zap it entirely in the process. That's the worst feeling ever. But don't kick yourself if that happens to you. This is part of our trade. We are made to suffer. It's our lot. Now let's see if we can get out of the hole we've just dug for ourselves. So we have ElectroBOOMed ourselves, and I still don't understand why it arced, because it shouldn't. It didn't arc the first time and it started to arc. Makes no sense to me. So we have to investigate in our favorite part of the circuit, the energetic and deadly high voltage supply. So first thing I checked is that my high voltage pros was working fine, and it is. I tested 100 volts and it gives me the required 100 millivolts, perfectly fine. I also tested all the low power voltages, they are there, no fuses has gone, so it's not any kind of simple damage. We have to go inside the power supply. So here we go, and let me inspect it, see if I see any signs of damage. I really would like to know where it arced, because that will probably give me a clue. So I spent a lot of time cleaning and inspecting to see any marks of arcing, and I could not. And on top of that, if you look at the board, it shouldn't have arced at all. No, maybe I touched something else, but if you look around here, this is all tied to the same potential. It shouldn't possibly arc with anything over here. It must have arced with the ground on this over here. And then finally I found that it arced right here at 2 points. So what happened is that my tip here is a little too fat. It just arced between the tip here and here. Now, what did I zap? And I already know I zapped the control board over here, because I get no oscillation in the primary. Let me show you that in the schematics. Oh, and by the way, the first thing you want to do when checking the power supply is remove this, because this is the power to the multiplier. So it's 3 point whatever kilovolts up to here. And then it goes into the multiplier and it goes 18 kilovolts, but we don't need it right now. So here is the glorious schematics, and at first I was intimidated by it, but then I finally understood that is actually not that bad. So what it is, there is a transistor here, and the collector goes into there, and the base picks up into here, and if you look closely, there's a dot over here and a dot over here, so it inverts the feedback, which means this will bring this into oscillation. And then there's a transformer, this guy transforms it to high voltage. I am missing oscillation, which should tell you that this part is not working, but I checked the transistor vaguely, it seems to be working. But you see there is more to it. There's this chain of transistors, and that chain of transistors is controlled by this over here. It's the voltage regulation. So it takes its output over here. There's a very large 30 megohm resistor. It's this fellow, which I checked, and it is 30 megohms. That comes back over here, and here is a 1 megohm, so it's a 30 to 1 divider. And that voltage gets amplified by an FET and 2 transistors and controls how negative this is, so that it takes a longer time for it to reach a positive stage, and so it will modulate the time the transistor is on and the energy that goes into there. I went into over here, and it's easy to test because it's low voltage. They give you all the voltages. I could check that none of the voltages were correct. This transistor has all its 3 leads at the same potential, so I think this one is completely dead. And this one is hard to test because it's a JFET. But my thinking is that if I arc to the ground, probably put a transient through here. So I got a large pulse, and that zapped probably this one and this one. This is the JFET over here. This is the transistor, which looks like it's shorted everywhere. And this is the output transistor. Then the output goes into here and controls the winding that goes to the base of the transistor, the power transistor, which is hidden behind here. You don't see it very much. It's this guy over here, and I checked it with the multimeter. It looks good. So I'm going to work on the assumption that I zapped one of those two transistors or both. This is a 3904 garden variety PNP. This one is a JFET. It's an N-channel depletion JFET. I had to look how these work. They don't work like MOSFETs at all. I think I'm going to desolder this one and also the JFET, see if I can figure out the JFET on the curve tracer. Okay, so I have desoldered Q2. I expect this one is totally gone. It should fail the simple multimeter test. And it's 7 ohms from the base to the emitter collector and 4 ohms in the other direction. 9 ohms across the whole transistor. Okay, so it's gone. It's been electro-boomed. Now what about a Q1, the JFET? And I think the JFET is the more fragile of the two, and if it's an over voltage, I bet you it's gone. Alright, JFET. Okay, figured it out. It's gate, drain, and source. And the JFET is gonzo. I am source and drain. I should have a resistor. I don't have a resistor, so depletion mode, it's on when it's not powered. And it's an open, and then if I check the junction between the gate and the drain, I have 80 ohms in that direction, which doesn't sound right. I should have a diode over here. I have 0.04 volts on my forward diode, and I bet you on the backwards diode, it's also 0.04 volts. 0.05, so it's gonzo. Spike voltage introduced by the spark, blew this, blew that. And lucky me, I can't believe it. I have it right here, 1855-0057, JFET N-channel depletion, 25 volts, 200 milliwatts. So I have like 3 of them, so I can do a couple more ElectroBOOM events before I run out of JFETs. Okay, so it turns out all the transistors were bad. And if they're all bad, probably the diodes are bad too. And I checked all the diodes and I only found one that's bad, a garden variety 1N4148. So that was easy to replace. So this one in the transistor that just got completely zapped, so I'm not surprised. And then I took this one out, tested it, and it's a hard one to replace. That's what the documentation says it is. But then it got a regular HP number written on it, and I looked it up. It's a 60 volt transistor, relatively high gain for the power. I don't have a direct replacement. I could replace it with something else, but right now I left it in. I'll just quickly turn it on, see if I have some oscillation. If not, I need to change the transistor. The last one I didn't change. Oh. Do I have a little bit of oscillation? No. I see it coming to 27 volt, but it's not oscillating. Okay, that's not a good sign. I have taken my driver transistor, the high power transistor, out and replaced it with this. 80 volts instead of 60, 10 amp instead of 5. More gain than this one had, so if that doesn't work, then I am sort out of good ideas for a while. And it doesn't work. But it didn't go to, I mean, what? Coupling DC and it stayed at 0. What the heck? Huh, it doesn't work, but in a different way. I have a tough time believing this one. Okay, Mike had a brainwave. It looked at the two transistors. There is a big difference. This one has metal all around, this one doesn't. It has metal on the back, which is fine, because the screw won't touch it and there's an isolator. But this one, there's an isolator, but the screw will touch it. So I probably grounded it. So I need to take my transistor off, and I need to mount it with a grommet. Good catch, Mike. This is why it always helps to have a buddy watching over your shoulder. Always. I have to try my collection of insulating grommets. I can try to run it like this.
That's true, yeah.
For a second, right? And then I can solve my mechanical problem. Nothing. And with running this thing with a collector ground, it could have caused some damage. Yes, it could then Mike notice that, wait, it goes through a fuse. So if I had grounded this, I would have destroyed the fuse, and I have. So that's a fuse. It's in the machine. It's right there. So I think I'm still believing in Mike. I think you were right. I grounded the collector. And the fuse blew because it's right there to protect the winding from dying. Okay. All right. All right. We're still not giving up. We'll give it a 1 amp. See if I get some quick voltage. Yeah, 28 volts. So I have 28 volts, and Mike is there. You don't hear him. He's there somewhere. There he goes for moral support. We keep blowing stuff today.
It's not been a great day.
No, nothing works. Actually, it works for a little while, then we blow it up. All right. No, I have the same problem as before. It goes there but doesn't oscillate. Okay, I am officially out of good ideas at this point. Man, this thing should absolutely oscillate unless I have blown the transformer, which looks very, very unlikely. So my circuit is not oscillating, so we thought maybe the transformer is not transforming, and we put some voltage from an oscillator on one winding, we got voltage on the other winding, there is no shorts between them, the transformer seems fine. But it's not starting, so my next thinking was, let's disconnect those two, and I'm going to force this one to oscillate by putting some oscillation from my trusty HP oscillator, not my trusty mic, trusty HP oscillator over here. And I put it through a 470 ohm resistor into the base of a transistor, and here it is, but 1 volt peak to peak, which is what they call out. And of course, it's always going to be 1 volt peak to peak because of the base junction of a transistor. And you can see when it hits the 0.6 base voltage, it just the transistor turns on. And then I am going to see if the transistor works. If it works, here I should get a voltage that should be the same as what I'm putting in, so it can sustain oscillation. And it actually works. All right, so if I turn it on, in green I have like 20 volts peak to peak, and in blue I have the voltage that comes back and sort of matches. It would oscillate over here. Naturally, it would oscillate at this frequency, right? So this works. I don't understand. It's just not starting up. By the way, I should be generating high voltage. Turn it off. So if everything works and my transformer works, and here I have 2.3 kilovolts. Oop, I have a little bit too much. So in a sense, it's comforting. We are climbing out of our hole. The whole magnetics working. The whole high voltage generation is working. The transistor seems to be working. I checked the voltage on the amplifier I repaired. Now everything seems more or less normal. It seems ready to spring into an action.
Yep.
The oscillator doesn't start. And usually in those oscillators, there is a starting circuitry. And I don't know where it is. I can't really find it. But it's not completely broken. It wants to do high voltage and the right amount and at the right frequency.
Mm-hmm.
So I changed the two capacitors I thought were responsible for starting, and I reconnected everything as it should. And no dice, it doesn't start. However, I can prove to you that it's a starting problem because I still have my oscillator wired in. Right now it's off, but I'll turn it on for a second and I'll turn it off and see if the oscillation continues. So I turn it on, it oscillates, I disconnect it, And voila! Now it has started. It is completely disconnected. So it wants to work, but I can't put my finger on what is starting it. So this is called a blocking oscillator, by the way. And I looked at papers and nobody seems to put any details on how the thing starts. So my thinking is that this circuit should actually self-start, and there are not that many components that we haven't checked. I'm just left with those two, which are super hard to check. So they are right there in conformal coating, so you have to scrape them to get at them. They are in circuit, so they are hard to check because you test the impedance of a transformer instead of diode itself. But I unsoldered one pin of one because I think it's wonky. This one, scraped it. In one direction it's 0.7, and in the other direction it is 0.4, so it's not a diode anymore. The other one in circuit 2.61 volts in the blocking direction, which is fine, and 500 millivolts in the non-blocking direction, so this one is fine. So hopefully this one is the one that prevents my stuff from starting. The question is what to replace it with. It says 0.75 amp, 200 volts, and I think I'll do this one, which is a 600 volts, 0.6 amps, close enough, but fast recovery because this has to work at 50 kilohertz. All right, new diode is in there. Question is, will it start on its own? It did. All right. Okay. Oop. It blew up. I bet I blew the fuse. I did. Man, I could see that it was not stable in the oscillation. There's still something wrong. Alright, I'm slightly confused at the present. So since I was blowing fuses, I went back to a configuration where I opened the loop. So my worry is that my loop is not regulating properly. So all I did is opened it here. So that's the signal that should come back at the transistor. I terminated on 1K. And here I'm putting back through a small resistor a drive. So I drive it artificially from the generator. And I also went back to my old homemade probe because I can hold it easily and I can watch the output voltage here, the high voltage. And as far as I can tell, everything is working fine. So if you look at that, in green, that's my oscillator. In red, that's the signal that's picked up back at the coil. That should be in opposite phase. It is. The blue is what comes at this point here. So that should be normally, that's what the transistor should be driven from. And it should be the rectified top portion of this, which it is. And the yellow over there, that's the input. That's the signal here at my divider that goes to my feedback loop. I am generating 2.78 kilovolts. You can see it here. I'm going to change the frequency a little bit so that I generate a little over that and see if I'm going the wrong direction, and see if the regulation kicks in. And it did. You can see it, it went negative. So it detected it went behind what it should regulate, and then it killed the feedback signal down, which is what it should be doing. So it's all working great. I don't understand that when I close back the loop, I blew the fuse. Doesn't make any sense. It's, as far as I'm concerned, open loop is working fine, and then the loop is generating the right control, so I should have repaired everything. I have hatched a new theory why I might blow the fuse when I close the loop. Before it goes into regulation, it's clamped over here by those two diodes to 1.4 volts, and they are the same type as those two diodes, including the one I replaced. So what happens is that you have 2 forward voltages of this diode minus 1 forward voltage of this diode, and that should be enough just to barely turn that one on, but not too much. But I have replaced that one, and I think its forward voltage, it's a more modern diode, its forward voltage is lower than these two. So therefore, when it's clamped over here, it gives too much of a current. It turns that one on too strong. It's a better transistor too, by the way, now. And I put too much current through the coil and the fuse blows. That would make some sense. So I have to put a diode here with a bigger forward voltage. So my contrived explanation would be that those two diodes here have to be the same types as those two diodes here, and I replaced it with a diode with a lower forward voltage, and I screwed up the delicate balance. That's the only thing I can come up with at this point. So instead I'm trying a more garden variety diode, the 1N4006, and I hope it's going to be fast enough to rectify the signal. So this is open loop. Yeah, it's doing its job. I'm going to close the loop again and see if I still blow fuses. But I'll just reclose the loop. So that's the pin that I used to drive by the external generator. Now it's going to be driven on its own and see if we blow it or not. Okay, something's not wrong. It's not oscillating at the correct frequency at all. I didn't get any high voltage either. It's oscillating at 600 kilohertz. Okay, we have another mystery. Gee, the thing does not want to work. I wonder if my transistor is too fast. That is the original transistor, which I replaced when I was worried it wasn't working fine. But now I know my regulation loop is working fine. So maybe I put it back in. I'm just worried this transistor is responding way too fast and it's driving a weird oscillation. Okay, old transistor is back in, it's slower. Let's see if that's making it run at the right frequency. It does. It does. Okay. What does it say? 61 kilohertz. That's perfect. Okay. Oh, it looks picture perfect. Am I generating high voltage? I am. It's regulated at 2.98. Can we adjust that? Let's try to not zap ourselves. Yeah, 3.1. See if I can go to 3.150, which is the adjustment we were trying to do in the first place. There we go. All right, 3.1497. Phew! That resisted us. So we are not completely out of the woods. We have to see if we can reconnect the 18 kilovolts, and that should load it quite differently, and see if it can re-regulate after that. We reconnect this, and we should be back in the original configuration and see if it can still regulate. Ooh. Hold on a second, guys. I think it is interfering with this. I have to move this a little further away. Okay, push the white wire a little bit away. See if that... No. It's arcing somewhere. Okay, try again. I removed everything. I think there was a ground wire that was a little close here. Ah. Better. There is high voltage. Okay. We don't have any arcing. Do we have beam? Nope. No beam. I might not have my 18 kilovolts anymore. Actually, I do think I have 18 kilovolts. If I take this out, sometime I can spy the beam. There you go. There it is. I do have acceleration voltage. Yeah, nice and bright. There you go. Nice on the other side. I put it somewhere in the middle. There it is. It's a gate voltage problem. The gate turns off. Cannot find a beam. Oh no! After much difficulty, including putting in modern replacement components that were too performant for the circuit, we finally repaired this recalcitrant high voltage supply. But our beautiful blue beam did not reappear, except in short bursts. Something else is broken. But frankly, at this point I am exhausted, so I'll try my best in the next episode. See you then!